Fossil footprints are known as ichnofossils. Fossil dinosaur tracks are common in the Paluxy Riverbed in Glen Rose, Texas. Among these fossil dinosaur tracks are fossil human footprints. As far as we know at present, the use of spiral CAT scanners to examine the internal compression of the host rock by ichnofossils is a new technique. Let us take a look at a medical X-ray. Medical X-rays are an exposed film negative. X-rays expose the film, so if there is something blocking the X-ray source, like a bone, the film remains unexposed, and when developed, it turns white. The less dense the material, the more the X-rays can penetrate, and the darker the shade in the X-ray image. The spiral CT, or computer tomography, is essentially an X-ray machine that can make three-dimensional X-rays. The images are captured by a computer and assembled. The images can also be assembled into two-dimensional slices through the subject, and these are referred to simply as X-ray images. When it comes to the controversial human ichnofossils of the Paluxy, the preferred evidence is entire trails of tracks excavated from underneath undisturbed limestone in the presence of multiple authenticating witnesses. However, there have been a number of tracks that have come to light over the years where the history is unknown. Proper documentation simply was not done because the ichno-fossil was found by a layman, or the track was not found in situ. One such track is the Delk track. It was collected in July of 2000 by Alvis Delk, an amateur archaeologist from Stephenville, Texas, who was wandering through the Paluxy. He flipped over a slab which had a pristine fossil dinosaur track on it. He took this home where it sat in his living room for 8 years. After an accident that left him in the hospital for many months, he needed to pay his bills and clean the slab in hopes he could sell the dinosaur track for a few $100s. This is when he discovered the slab also had a human ichnofossil in it, which was still covered by dried clay. Because the slab was found loose in the riverbed, its original location is not known, and indeed there was the possibility that it was a carved track simply planted there by a forger. So Dr. Carl Baugh, director of the Creation Evidence Museum, conceived of the idea to use a medical CT scanner to look for compression in the rock matrix. The two tracks were originally made in mud, which has now hardened into rock. When a foot steps into mud, it displaces the mud and compresses it in various areas. If this mud were to harden into rock, then the rock would still preserve the compression surrounding and underneath the tracks. When Paluxy dinosaur track cross-sections are exposed, either by a ledge breaking off across a track or by deliberate sectioning of a track by a scientist, there is often no visible compression effects in the rock matrix underneath the track. To be more specific, there is often very little compression underneath the track, but considerable compression surrounding a track, especially the toes. This has more to do with the foot displacing the mud in a fast, forceful way rather than compression by load bearing. This is counterintuitive and has hindered dinosaur track research over the years. Sectioning a track is destructive, and while the presence of compression effects in the matrix can be very instructive and definitive, the lack of compression effects within the matrix provides no real conclusions and is not necessarily indicative of a carving, as some have suggested. And so, CT X-rays can play a role in non-destructive examination of compression within the rock. The Delk track was taken to the Glen Rose Medical Center's spiral CT scanning laboratory, where over 800 X-ray images were produced from the track. Let's examine these X-rays, starting with the scan looking straight down on the slab. The scale is in centimeters. As we enter the rock, we are viewing a thin slice only a few millimeters below the surface. We are inside the dinosaur track and inside the human track. Remembering that these are X-rays, white represents the most dense rock, whereas the darker the shade, the less dense the material. At this point, the rock appears as white, but the tracks are black because there is no rock inside the tracks, and thus no resistance to the X-rays. There is a distinct white line of higher density rock around both the dinosaur track and the human track, several millimeters across. This is higher density